Hi, everybody. Let's talk about prime factorization. You should realize that most numbers, well, technically not true, but many, many numbers are composite numbers. And a composite number, like the word composite, it means it's made of other things. It's built from other things. Sort of like if you've played with Legos before, you know that you can take a bunch of Lego blocks and put them together and make something like a house or a dog or something. And that model is called a composite figure. It's made of Lego bricks. Now, composite numbers are not made of Lego bricks. They're made of prime numbers. Right? Prime numbers are numbers that can't be divided any longer. We've talked about that in class. So let's take a look at a composite number that we're going to break apart into its bricks or its prime numbers. I'll make it even, because even numbers are easy to start with. Even numbers can all be divided by 2, right? So I know that 2 is one of the smallest prime numbers. Now I just need to figure out 2 times what equals 252. Right, so 2 is a factor. What's the other missing factor? And sometimes you have to do a little division to figure this out. So I'm going to do a little side work. 252 divided by 2 would be 1. And I'm going to skip over some of this. We call it speed math, right? 52, and that would be 2. That would make, there'd be a 4 there, and we have 2 left over. Actually, that's a 12 left over, and that would be a 6. Da-da-da. So we found our missing factor. It is 126. Now, you just kind of have to decide which of these are prime. Let me erase this side work. Are any of these 2 factors prime? And the answer is yes, 2 is prime. Okay, so I'm going to put a little circle around that, telling me that that branch of the tree is not going to grow anymore. Okay? 126, again, that's even, so I'm going to break it into divided by 2, because it's the easiest thing to do. And this one I can sort of mentally figure out that that's going to be 63. And you could do side work if you can't see that. Right? You could do the division problem again. So 2 is prime, and I'm going to keep trying to work with 2's because it's easy to divide by, it's easy to see, but I'm kind of stumped here. 63 is not even, can't be divided by 2. So I'm going to have to think about some other tricks. Divisibility rules, we call them. Like you might remember that if you take the 2 digits in a number, in this case the digits are 6 and 3, and you add them together, the sum of 6 and 3 is 9. And 9 can be divided by 3. 9 is divisible by 3. That means that 63 is divisible by 3. So let's do it. I'm going to divide that by 3. And you notice I'm always trying to keep the smallest prime number I can on the left side. It helps keep the tree organized a little bit. Okay, and it keeps the numbers from smashing into each other. So 3, that's a prime number, but 3 times what? Well, in this case, it turns out it's 21. 21. I'm going to put a circle around the 3 because the 3 is a prime number. Oops, I kind of missed it. I'm going to put a circle around the 3. It's a prime number. And 21 I'm going to keep factoring, right? 21, what 2 factors make 21? Well, I can do that trick again. 2 plus 1 is 3. I can divide it by 3. Oh, that's right. 3 times 7. Now, 3 is a prime number. I'm going to put a circle around there. And it turns out that 7 is also a prime number. Right? Getting to know those primes is just a matter of habit. It'll take a while. But you might realize that 7, there's no 2 multiplication, there's no 2 numbers you can multiply together to make 7 other than 1 and 7. Now you might realize we're not going to keep doing stuff like, oh, well, I could do this. We could write this as 1 times 2, and I could write this as 1 times 2, and I could write this as 1 times 2. So you don't want to do that, right? When you get to a prime number, you want to accept that that's the end of the tree. All right, so here's our prime factorization, and we can write it out like this. 2 times 2 times 3 times 3 times 7, all equal. If we multiply all those together, we will get the composite number of 252. That's a composite number. You could also rewrite it in its exponential form. We could say 2 to the second power times 3 to the second power times 7. That also equals 252. So that's our prime factorization. And then we can use that for lots of other things in life. But there it is, step one, prime factorization. Good night.